All right, this is a very brief lesson where we are going to look at just a little odds and ends when it comes to isomers. I'm going to apologize right now. My children are really loud. We're playing, I don't even know what. But I wanted to get this video done so it's available to you. So we're specifically looking at two kinds of isomers in this brief little lesson. One of them is when there are isomers of an alkyl group. So this means that when a side chain has a different arrangement of atoms, or they differ by how they are attached to the parent chain. Now, as your alkyl group increases in number of carbons, the different arrangements obviously are going to increase as well. We are only going to look at two alkyl groups. One is the propyl and one is butyl. Okay, so if you came to my office hours, we talked briefly about the propyl group. And there are two different ways that a propyl group can attach to a parent chain. So the first way is when we're going to use, let me see, pink. We'll use pink. We're going to use pink to represent the parent chain, and we're going to use R. That's pretty common for R to represent the parent chain, and you're going to see me do this really frequently in the next week. So the way that you have seen a propyl group attached to the parent chain before is when the propyl is attached to the parent chain using an end carbon. And you might sometimes see this called N-propyl for normal. Or sometimes people don't even use the N and they just say propyl. All right, the other form of an isomer of the propyl group is when we have our three chains. It's still a propyl side chain, but this time it is bonded to the parent chain on the middle carbon. And when we see that, this is called isopropyl. Gosh, my children are wild upstairs. Isopropyl. So if you see a propyl group attached to the parent chain via the middle carbon, you use iso to denote that it's attached to the middle carbon. And the reason we have to do this, we have to distinguish how it's bonded, is because they're going to have slightly different properties. Something with a propyl group is going to have slightly different properties than something with an isopropyl group. Okay. All right, so now we'll look at the isomers of our butyl side chain. The first one should be fairly straightforward. Again, we're going to use our R for our parent chain. And this is just exactly how we've seen a butyl before, where our parent chain and our butyl alkyl side chain is attached at the end. And this is called N-butyl. Okay, so N again is normal. And sometimes you will see it called 1-butyl. Okay, so this is because, again, the N or 1-butyl is because it's attached to that end carbon. The next butyl side chain is going to look like this. CH. It's not true. Delete that. It's just one H. Here, it's when our parent chain is It's when our parent chain is attached to the second carbon in our side group. So we get something that looks like this. This is called S-butyl. For secondary, because it's on the second carbon. But it's also just called 2-butyl. So sometimes you'll see it called S-butyl and sometimes you'll see it called 2-butyl because that R is attached to the second carbon. All right, the third isomer of our butyl side chain is going to look like this. We have CH3, and our parent chain is connected to the second carbon, but that second carbon also has a methyl group on it. So you will see this named T-butyl, which kind of makes sense because it looks like a T, or tertiary butyl. But the other way that you might see it is
it's going to be a no.
Oh my goodness, sorry. Okay, so this is T-butyl or tertiary, and you might also see this called 2-methyl butyl because the methyl is on carbon number 2 in the butyl side chain. And then our last isomer of our butyl side chain looks like this. So CH3 CH2. It looks like this. And this is, I'm going to squeeze it in here. This is isobutyl. And you might also see it called 2-methyl propyl. All right, the last kind of isomer we're going to look at is isomers of benzene. And I've drawn the three different isomers of benzene. They both have 2 methyl groups bonded to it. But as you can see, they're isomers because the methyl groups are bonded to different carbons. So there is an old way of naming, a traditional way of naming these aromatics that use Greek prefixes to distinguish what 2 carbons that the alkyl groups, the side chains, the branches, whatever it is bonded to the benzene. Now, I have used 2 methyl groups. It does not have to be 2 methyl groups. It could be any type, anything bonded to a benzene. We're going to be introduced to a whole bunch of new functional groups that are also bonded to hydrocarbons at the end of this week. So I'm just going to quickly number the carbons on all 3 of these isomers. All right, so there we've got our carbons numbered. If we look at our first isomer, we can see that the position of whatever we're dealing with is on carbon 1 and carbon 2. And so this is, it gets the prefix ortho. And so this gets shortened to O. So this would be O. I'm just going to hit pause here. Hold on. O dimethyl benzene, or it's also like 1,2 dimethyl. So you will see these lettered prefixes being used. So it's just important that you recognize that it's just the O is telling you that the O is telling you that the side chains are on carbon 1, 2. If we look at our next isomer, we're going to see that they're on carbons 1 and 3. And when they're on 1 and 3, the prefix that they get is meta. So you might see something, this being M. I'm sorry for my children in the background. I'm just ignoring whatever they're doing for a minute. This is going to be M-dimethylbenzene. So you're running out of space. Or you might also see it called 1,3-dimethyl. Okay, so the important part here is that if you see the M prefix, know that they are talking about the side chains being on carbons 1 and 3. Okay, and so in our last one, we're going to see that they are on carbon 1 and 4. And I'm going to squeeze it in here. When we have our side chains on carbon 1 and 4, it's para. So, all right, so this is going to be P. Okay, so sorry. The P means that they're on carbons 1 and 4. It gets the prefix para. So if you saw P dimethylbenzene, you would know that they're on carbons 1 and 4. It's also going to be named, you might see it named 1,4-dimethylbenzene. So the reason I'm showing you this is because a lot of people still use this traditional method of naming. And if you come across it in your future organic chemistry education, you're going to at least know what they are meaning. Okay. If you see an isomer of benzene, I expect you to name it properly. You can probably just use the numbers, but I might ask you what the O or the M or the P means. Okay, so we talked about 3 different types of isomers today, mostly having to do with how carbons and side chains can be arranged. And then our benzene, looking at how our side chains can be bonded to different numbered carbons in a benzene ring.